In this video, we're going to learn how to compute the income and substitution effects. Amir has $64 per week to spend on his favorite treats, baklava and Turkish coffee. His utility function over these two goods is given by B times T, where B is baklava and T is Turkish coffee. When the price of a baklava is $8 and the price of a Turkish coffee is $8, Amir's optimal basket is B equals 4 and T equals 4. When baklava goes on sale for $2 and the price of a Turkish coffee is still $8, Amir's optimal basket changes to B equals 16 and T equals 4. Our goal is to determine how much of the observed 12-unit change in baklava consumption is the result of the substitution effect and how much is the result of the income effect. What do we need to know in order to answer this question? We need the consumer's utility function, we need the initial prices of each good, we need the final prices of each good, and we need the consumer's income. Solving this problem is quite complicated. It's a multi-step process. So first we need to find the initial basket, so the utility maximizing choice at the initial prices. Then we need to find the final basket, the utility maximizing choice at the final prices, the second set of prices. Finally, we need to find what's called the decomposition basket. Once we have that, it's a matter of subtracting. The substitution effect is the difference between the decomposition choice and the initial choice, and the income effect is the difference between the final choice and the decomposition choice. So we need to at least briefly talk about how we find the decomposition basket. It's going to have two properties. First, it captures the new ratio of prices. So that means that we're going to have a tangency condition where the ratio of marginal utilities is equal to the new ratio of prices. So in the question that we're working here, the price of baklava falls to 2, so the new ratio of prices is 2/8. Not only does it have to do this, we need our decomposition basket to also achieve the same utility as the initial basket. How do I write that? I can think of the utility from the decomposition choices BD and TD as being equal to the utility from the initial choice. I know this seems very sort of opaque right now, but as we move through the question, these two conditions will become much more understandable. So let's solve this thing. It's really useful to start by writing down what we know. We know the utility function. We know the initial prices are 8 and 8. And this question is kind because it also tells us the initial basket, so we don't have to do that work. We know that at the initial prices, Amir buys 4 baklava and 4 Turkish coffees. We also know the final prices. The price of baklava falls to 2, as well as the final basket, 16 baklava and 4 Turkish coffees. So again, this question is nice because we kind of have steps 1 and 2 done already. We know the initial choice and the final choice. So what we need to do is we need to find the substitution and income effects. And in order to do that, we need to find the decomposition basket. So the decomposition basket had those two properties. And in order to sort of execute those two properties, we first need to know how much utility Amir actually earns from that initial basket, because we know his decomposition basket also has to have that much utility. This one gets students, don't overthink it. Utility is a function. You just evaluate the function at the initial choice. So his utility from the initial choice is equal to BI times TI. Well, there's the initial basket, so it's 4 times 4, which is equal to 16. We'll need that later. Another thing we need to do is we know there's this tangency condition associated with the decomposition basket where we're taking into account the ratio, the new ratio of prices, and that tangency condition requires that we know the marginal utilities. So we've seen this kind of utility function a lot. The marginal utility of B is just the partial derivative with respect to B. That's going to be equal to T. And the marginal utility of t is the partial derivative with respect to t. Well, that's going to be equal to b. So using this utility from the initial basket and our marginal utilities, we should really easily be able to find the decomposition basket. Remember, it has two properties. It has to capture the new ratio of prices. Ratio of marginal utilities equals 2/8 because that's our new price of baklava. And we also need to make sure that the utility we get from the decomposition basket is equal to 16, that number that we just solved for on the previous slide. So let's fill in what we know. The marginal utility of B is T, and the marginal utility of T is B. That has to equal 2/8. It might be helpful if you label these things TD and BD so that you understand that these are the decomposition values. So we're going to call this equation 1, and then we're going to fill in what we know over here for 2. So 2 tells us utility from the decomposition choice has to equal 15. We just have to fill in that formula. So we have BD times TD has to equal 16. That's equation 2. So before we move to the next slide, take a look at this, recognize that the two properties of that decomposition basket generate two linear equations with two unknowns, and we should very easily be able to solve for both TD and BD, the decomposition basket. So we're going to take these two conditions that our decomposition basket has to meet, and we're going to solve equation 1, that tangency condition that takes into account the new ratio of prices. We're going to solve that for TD and how TD depends on B. So this is just a simplification exercise. I have TD is equal to 2/8 times BD, and then we can simplify and say TD is equal to BD over 4, and we can call that equation 3. Now we're going to take that equation 3 and we're going to substitute it into 2. So in particular, we sort of use this equation to generate this equation. And now we need to use that second condition where the decomposition basket generates the same amount of utility as the initial choice. So I plug in what I know. I have, in place of TD, I have BD over 4 times BD is equal to 16. Now this isn't super fun because we're going to have a square term. So I have BD squared is equal to 16 divided by 4. Sorry, times 4. Don't be like me. 16 times 4, which is 64. And then I want to solve for B. So how do I get rid of the square term? I raise both sides of the equation to the 1/2 power or the 0.5 power if you prefer. So I find out that the decomposition choice of B is equal to the square root of 64, which is 8. We're going to call this equation 4. Now that we know that the decomposition choice of B is 8, all that's left is to substitute equation 4 into 3, and that's going to allow us to solve for the decomposition amount of Turkish coffee. So TD is equal to 8 divided by 4, which is 2. So we've done a lot of work, but we're really not quite done because all we've done is found the decomposition basket, so we still need to subtract appropriately. In order to find the substitution and income effects, we need to execute the appropriate subtraction. In particular, the substitution effect is the difference between the decomposition basket and the initial basket. So I'm going to circle the initial basket over here. So the math that we're doing is 8 minus 4 is equal to 4. The income effect is the difference between the final basket, that's 16, and the decomposition basket, 8. So the math that we're going to do here is 16 minus 8, which is 8. So we could conclude that when the price of baklava falls from 8 to 2, and we see a subsequent 12-unit increase in the consumption of baklava, 4 units of that increase comes from the substitution effect. So we can picture ourselves like pivoting around the original indifference curve. And then another 8 units of that increase comes from the income effect, where we're shifting to that higher indifference curve.